Hello, my name is Coby Johnson. For my senior project, I have decided to make an AI agent for the game Abalone. My chosen core tasks are 1. Make a working Abalone game in Professor Larson's AI framework. This game will be used as a future homework assignment in the CS 4300 class. 2. Make an ASCII game board to help with the testing of the board class that is required to make the game work within the framework. My hope tasks are 1. Make an OpenGL game board that can be used by the framework. Number 2. Develop a random AI heuristic to act as an agent to test playing a game and make sure the server, agents, and display work properly within the framework. 3. Have the determine legal moves method in the board class determine an easy subset of the legal moves for testing the Abalone agent. My dream task is to make multiple AI heuristics that are able to play the game Abalone. Abalone is a board game played on a hexagonal board. Traditionally, it is played by 2 opposing players, but can be played with 4 players as well. To win a game, a player must push 6 of the opposing player's marbles off of the board. Legal moves involving moving groups of 1 to 3 marbles of your own color in a line. I'll show you a few examples here from this picture I got off Wikipedia. Say it was Black's turn. Black may choose these 3 marbles to move. These marbles can legally move up, 1 and to the left, diagonally in a broadside inline movement. Or, alternatively, Black could choose to move these 3 pieces up diagonally 1 space or down diagonally 1 space. Also, 2 marble moves, such as this one, are legal, or 1 marble moves, such as this one, are legal. White can do the same. With these grouping here, can move 1 to the left, or say these 2 marbles can move up or down. The game gets more interesting when you factor in legal pushing moves. A legal pushing move involves pushing 2 or 3 of your pieces into 2 or 1 of your opponent's pieces. For example, if it was White's turn, White could pick these 2 pieces and push it down and to the right into Black's piece, forcing Black's piece to move to this slot here. Alternatively, White could choose to push with all 3 of these marbles to push Black's piece into that same slot. If it was Black's turn, Black could move these 3 pieces to the left, pushing these white pieces to the left as well. Pushes are only valid with 3 or 2 pieces. If you're pushing 3 pieces, you can push 2 or 1 of your opponent's pieces, but if you're pushing 2, you can only push 1 of your opponent's pieces. Now that you know the basic rules of Abalone, I wanted to show you how I was able to get Abalone working within the framework for the CS 4300 class. There are 3 parts involved with the framework: the server, the display, and the agent part of the system. Each of these parts have to be built individually, but once you're done, the script can be made to run all of them, so you can test it pretty easily. I'm going to show you now, once I run this, what actually happens. So right now the server's starting up. Once the server starts, it creates this display, and this display allows you to see what the agents are doing. As you can see, there's a red agent and a blue agent playing, and they both are random agents at the moment. These random agents just pick a piece and move it on the board. As you can see, they're only making one piece moves at the moment. That's as far as I was able to figure out. With the complexity of the code, it was a lot harder than I thought it would be to actually even move just groups of 2 marbles together. It turned out to be a lot harder than I ever thought it would be. As for the code of the project, some parts were easy and other parts were pretty hard. For example, making a random pick agent was actually quite simple, because once the board can determine legal moves, you just randomly pick one and tell the server to move using that move. So the agents are pretty simple. A little more complex is the environment, or the display. The display It turns out to be, 370 lines of code or so. And this is what actually draws the board on the screen. The core of all this code is the basic board class. The basic board is the physics or the rules of the game. So there's quite a few functions here. Turns out to be a pretty big file as well. There's things here like initializing and setting up the board. There's converting the board to a string format so it can communicate, so the agents in the server can communicate. There's other helper classes. And this one that was an agent is determine legal moves. What this does is this um, determines all legal moves for the board as it says, but the hard part is actually determining those moves, especially in a game as complex as this. This game is actually about as complex as the game of Go in terms of space of moves that you can take per turn. So right now what it's doing is for every slot on the board, if that spot is equal to your color for the player that's moving, that you want to generate moves for, it will try to move that to one of the slots around it. And if that slot's available, or if it's empty, then it will make it into a move and add that move to your legal moves that gets returned at the end of the method. I am very happy with what I was able to accomplish this semester. I was able to develop my environment, the display for that environment, and also a random agent to test out the environment. With those three things, I fulfilled my core and my hope tasks. As for the changes that I had to go through while doing this project, this is actually my second project I've attempted this semester. My first one was going to be a website for my friend. Unfortunately, that fell through about 3 to 4 weeks into the semester. And so I went and approached Professor Larson, and we discussed making a new AI project for his class. And we decided to make the game Abalone because it's another min-max game substitute for Chinese checkers. Overall, I've put about 50 hours into my senior project. It's been a really fun one, and I hope that I can continue to work with Professor Larson to make this project better in the future for future students.